Hello ladies, it's Mr. O'Sullivan. Today is a Zoom lesson, so this video should only really be watched if you missed the Zoom, but you shouldn't miss the Zoom because that's the only class you have at that time. So today what we're going to be doing is we're going to be learning about our final way of solving systems of equations, and that's graphically. Just give you the heads up, graphically does work for every single system. However, the only time you can actually find the right answer or the best answer is if the lines intersect at a nice point. And when I mean a nice point, I mean points that occur like here, here, here. The minute you get a point somewhere like this, makes it very challenging because you don't exactly know what that number is. It looks like it could be 1, 2, 3, 4, 5, 6.5, but it could be 6 2/3 for all we know. So let's see what we're going to be doing today. The learning target for today is I can solve systems of equations by graphing. So just so we can remember what the definition of a system is, a system of equations is two or more equations that need to be solved simultaneously at the same time. The solution is the point that makes both equations true. On a graph, it is their intersection point. So if I have a graph and I have two systems drawn on it, just pretend this is what your graph looks like. Oh, sorry. Pretend this is line 1. This is line 2. Your point of intersection would be right here. What we typically do is we mark it with an X. So, question number 1, is the point 2, 5 a solution to the systems of equations provided? Well, the system of equations provided is y equals 4x minus 3 and 2x plus y equals 9. So here's our procedure to figure out if the point 2, 5 is a solution to that system of equations. All we're going to do is plug in the point 2, 5 into each equation. The first thing we need to remember is that the 2 is our x-coordinate and the 5 is our y-coordinate. What I like to do is I like to have the equations organized like this. I think organizing it like this is very well, where you have the two equations completely separate from each other. So in our first equation, we have y equals 4x minus 3. What I'm going to do is I'm going to copy and paste that point. That way I know that's the point I'm working with. So everywhere I see an x, I'm going to substitute a 2. Everywhere I see a y, I'm going to substitute a 5. So I put my 5 right here and my 2 in right next to my x. So I get 5 equals 4 times 2 minus 3. Now you're going to be like, Mister, how do I solve this equation if there's no x value anymore? Well, you're not solving. What you're going to be doing is you're just going to be combining and simplifying to make sure that there's one number on each side of your equal. So if you look, I have one number here, so that's good, but I have a few too many numbers over here. So I just keep on bringing down my 5 for the ride. I have to ask myself what 4 times 2 is. Well, 4 times 2 is 8. And then I do my minus 3. And then I have to ask myself what 8 minus 3 is. Well, 8 minus 3 is 5. So I get 5 is equal to 5. I like that 5 equals 5. So that works right now. Here's the issue. I also need it to work for equation number 2. It can't just work for one equation. It has to work for both equations. So I'm going to do the exact same thing. I'm going to put my point right here. That way I know that's the point I have to use. And everywhere I see an x, I'm going to substitute a 2. And everywhere I see a y, I'm going to substitute a 5. So I have 2 times 2 plus 5 equals 9. I have to ask myself what 2 times 2 is. Well, 2 times 2 is 4. And then I have my plus 5. And that's equal to 9. 4 plus 5 is 9. So I get 9 is equal to 9. Since I have 9 equal to 9, that also works. So I can actually say that the point 2, 5 is a solution to the systems of equations. So we're just going to write a quick sentence, and we'll just say, yes, the 0.25 is a solution to the system of equations. Perfect. Now, let's go on to solving systems graphically. So here's the procedure for solving a system graphically. Identify your slope, identify your y-intercept, and then graph it. Since we're going to be doing these on delta math, make sure you write down the equations on a separate sheet of paper and write down the slope and y-intercept. That way you can plot it correctly on delta. So I like to color code my graphs. So I'm going to color code and write down y equals 2x plus 5. And then I have y equals negative x plus 2. Okay, so if I look in my first equation, before we begin, let's just make a quick note. We know linear equations are written as y equals mx plus b, where the m stands for your slope, and the b stands for your y-intercept. So if I look, the number attached to my x is a 2, so I can say my slope is 2. And what I'm going to do is put it over 1. That way I have my rise and my run. And then my y-intercept is 5. So what I'm going to do is, before I even look at the red graph, or the red function, or the red equation, I'm going to actually plot the points for 2x plus 5. So I know that my y-intercept is at 0, 5, so I'm going to go up to 1, 2, 3, 4, 5, and plot a point. And what I'm now going to do is go up 2 over 1, because my rise over run is 2 over 1, so 1, 2, 1. And now I'm out of room, so I can't go. So now I'm going to go down 2, so 1, 2, and over 1. And I'm going to keep on doing that. 1, 2, 1. Go down 2, 1, 2, 1. Rise down 2, 1, 2, run 1. And keep on going until you run out of room. So 1, 2, 1, 1, 2, 1, and I'm out of room. So now I'm going to draw a line going through those points. Ooh, doesn't look that nice. Not bad. And now I have my line drawn. Now, what I'm going to do is do the exact same procedure for my red function, where my y equals negative 1x plus 2. If you look, the number attached to my x is a negative 1, so my slope is negative 1 over 1. So my rise is negative 1, and my run is 1. My y-intercept is the number hanging out by itself, so in this case, it's going to be a 2. So I'm going to plot a point at 0, 2. And now I'm going to go down 1, over 1. So down 1, over 1, down 1, over 1, down 1, over 1. So as you can see, I'm plotting a bunch of points in this nice straight line. So down 1, over 1. And I'm going to keep on doing that until I run out of room. Now, I ran out of room, so I'm going to go back to my y-intercept. And now this time, instead of going down 1, over 1, I'm going to go up 1 and to the left 1, up 1 to the left 1, up 1 to the left 1. So I go up, over, and I keep on doing that until I run out of room. And now that I have all these points plotted, I'm going to draw a line going through them. And if you look, my lines intersect right here. So my point of intersection would be negative 1 and go up 1, 2, 3. Negative 1, 3. So my final answer would be negative 1, 3. But here's the issue. We want to make sure that you can check your answer. So all we're going to do is we're actually going to plug that point, -1, 3, into each system. Well, not each system, but each part of our system. So my equations are y equals 2x plus 5 and y equals negative x plus 2. What I'm going to do is copy their equations. So I have my y equals 2x plus 5. And then I have y equals negative 1x plus 2. And if we remember, this will be our x value. This will be our y value. So everywhere I see a y, I'm going to plug in a 3. So I have 3 equals 2 times negative 1 plus 5 now I get 3 equals 2 times negative 1 is negative 2. And then I do my plus 5. Now negative 2 plus 5 is 3. So I get 3 is equal to 3, which works. So you don't have to do this for every single question, but when it says check your answer, you actually have to show me the substitution. We're now going to do the exact same procedure on our linear equation on the right. So everywhere I see a y, I'm going to plug in a 3. So I have 3 equals negative 1 times negative 1 plus 2. Negative 1 times negative 1 is 1. So I get 3 equals 1 plus 2. And 1 plus 2 is 3. So I end up getting 3 equals 3, which works. So this shows me that this is a solution to my systems of equations. Let's go on to our next example, where we have to solve it again by graphing, but we don't have to check our answer. So in my first equation, I have y equals 2 minus 1/4 x. In my second equation, I have y equals 5/4 x minus 1. So the first thing I'm going to do is I'm going to rewrite these equations. So I have y equals 2 minus 1/4 x. And then I have y equals 5/4 x minus 1. So if I look, this is not in y equals mx plus b form. So I'm going to go up here and copy and paste my y equals mx plus b. In y equals mx plus b form, my slope comes first, and my slope is the number attached to my x. So I actually have to move my negative 1/4. So this equation is actually y equals negative 1/4 x plus 2. So now that I have this, I can identify my slope and my y-intercept. So in this example, my slope, the number attached to my x, is negative 1/4. So I can say m equals negative 1/4. So negative 1 is my rise, 4 is my run, and my y-intercept is the number hanging out by itself, which is a 2. I'm now going to plot that graph. So I start at 0, 2, and I go down 1 and to the right 4. So down 1 and to the right 4. So 1, 2, 3, 4. And then I go down 1 over 4. 1, 2, 3, 4. I ran out of room, so now I'm going to go back to my y-intercept, which is right here, and go up 1 and to the left 4. So up 1, left 4. 1, 2, 3, 4. And I plot a point. Then I go up 1, left 4. So 1, 1, 2, 3, 4. And now that I have these points plotted, I'm going to draw a nice line going through them. That's the best I can do. Now I'm going to go to my y equals 5/4 x minus 1, and I'm going to identify my slope. Again, the slope is the number attached to my x. So in this case, my slope is 5/4. So m equals 5/4. 5 is my rise. 4 is my run. My y-intercept is the number hanging out by itself. So in this case, it's a negative 1. So we go down to negative 1. And now I'm going to go up 5 over 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Up 5. 1, 2, 3, 4. I ran out of room, so now I'm going to go down 5 over 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So now I have this. And now I'm going to just draw a line going through these points. And if you look, it intersects here. So I can only estimate this answer. It intersects right here. So my answer for this one would be 2 comma something. So I know it intersects at x equals 2. So I have 2 comma something, because this is x equals 2. So what we're going to do is we're going to go to one of our equations and we're going to plug in 2. So I like the second equation because I don't like having to deal with the negative 1/4 x. So my second equation is y equals 5/4 x minus 1. And everywhere I see an x, I'm going to plug in 2. So 5/4 times 2 is 10 over 4. Well, actually, it reduces. 5 times 2 is 10. 10 divided by 4. I can reduce that to 5 halves. So I have y equals 5 halves minus 1. I just type this into Desmos, and I get y equals 3 over 2. If you look, that actually makes a little sense, because I go up 1, and then I have my 1.5. So I can say that my solution to this systems of equation is 2 comma 3 over 2. Because remember, it always goes x comma y. That's it for today. If you have any questions, please email myself or Miss Townsend, and don't forget to do your Delta Math assignment. Have a great day, ladies.